Welcome to STC Fiber Implementation Guidelines Training. This course covers the subjects in the Fiber Implementation Guidelines that are shown on the screen. We'll start by the installation of fiber cables in conduits, and we will cover cable placement by pulling, cable placement by blowing, fiber splicing, fiber optic splice closures, terminal installation, earthing, connectivity and patching, identification and labeling, and optical testing. These are the main sections in the Fiber Implementation Guidelines that we will see in this video course. Please bear in mind that this video course, does not replace the study of STC Fiber Implementation Guidelines document if you guys are intending to get STC certification on fiber installation. It is mandatory to thoroughly study the guidelines document as well as the concepts explained in the video course are the most important ones, and only the guidelines document covers in details every single subject. Let's move on then to the first subject, the fiber underground installation in conduits. This section covers general concepts about fiber cable installation that are later on other sections, but basic concepts about fiber optics and the physics around this cable installation are reviewed in this section. There are three main conduit sizes in the market.
What we call large-sized ducts, standard ducts, and micro ducts that are made of different materials. So large-sized ducts are typically concrete, PVC, or HDPE made, whereas ducts and microducts are made of HDPE. Typical dimensions in the market, depending on their size, are stated here. So the large size are considered from 75 millimeters and above. In telecom applications, it's rare that we go beyond 14 centimeters outer diameter, but in STC specifically we only use two types of large-sized ducts, and these are most commonly used for copper networks. They are the 110 millimeters and the 75 millimeters. This is an STC. Again, in the market for standard ducts, we have typically between 18 and 63 millimeter ducts. The sizes standardized in STC are 20, 25, 32, and 50 millimeter outer diameter ducts. Then for microducts, there is common understanding on the size. Between 14 and 18 millimeter is the borderline between microducts and ducts. So in STC we only use one type of microduct so far, that is the 12/8. So what is the most important performance characteristics in conduits? It is what we call, and you can see it on your screens, the coefficient of friction, COF, the acronym. Coefficient of friction. This is the most important performance parameter in conduits. What is the coefficient of friction? It is the force preventing you from installing the cable by any type of installation method. If there was no coefficient of friction, so no friction at all, you could install thousands and thousands and thousands of kilometers with no issues. Okay, because that is not the case. The coefficient of friction plays a very important role in fiber cable installations. This coefficient of friction is increased by these parameters here. dirt or contamination in both ducts as well as cables. So it is very important that you guys keep both clean at all times and that you guys keep the ducts sealed. We will see that later on. So dirt or contamination is the first point. The second point that is decreasing in this case the coefficient of friction is the type of inner surface. Okay, manufacturers have engineered different inner surfaces in the duct that are actually making it easier to install the cable. Lubrication is an important factor as well. Obviously, when you lubricate the cable or the cable and duct installation, you will reduce the coefficient of friction and you will gain distance. Last but not least are the conduit deformations and deviations, the bends. And this is not only on the horizontal plane, but also on the vertical plane. So be aware of deformations and deviations that may be preventing you from installing the cable all the way you want. So what are the techniques to install cables into conduits? We are going to see now the most important ones, actually pretty much the only ones. The first installation technique is cable pulling. Cable pulling is performed by applying a force at the cable head. So this is the cable head, as you can see in the drawing. Here you have your cable drum, the green line is the cable, and at the cable head we attach something. We will see that later on in details. And by means of a machine like this winch we have on the right hand side, or people pulling from the pulling rod, the cable is installed inside the conduit. So pulling means applying a force, a traction on the cable head that makes the cable pass through the conduit all the way to the far end. This can be done in two ways. The cable head attached here actually can be at the same time helped by an air-powered piston, so this is helped by air, or can be done by a pulling line. In most cases, worldwide as well as here in STC, we use the second method, pulling the cable using a pre-installed pulling line. Okay, so this is the pulling cord or pulling line that is pre-installed in the duct, and then we tie up the cable head to this pulling line and we pull from the other end to install the cable. But you guys need to know that there is a second method, that is the air power piston, helping the installation by insufflating air inside the duct. The next installation method is pushing. Pushing is the opposite to pulling, as all of you know. So pushing a cable does not require the utilization of a pulling cord. Pushing is mechanically or manually pushing the cable inside the conduit. So it's an easy installation method, no complication here, and no need for pulling line. However, because of the buckling effect that you can see on the drawing, the buckling effect is that the more you push a cable inside, the more resistance the cable will make against the conduit inner walls, making it bend more and more. And the more it bends, the more resistance to the pushing it presents. So this is actually limiting to very short distances the installation length. This method in STC is only used and only allowed for lengths within 300 meters, so up to 300 meters, and never with pushing forces that exceed 1000 newtons. These are illustrative values, but they are a good reference. You have to keep in mind that pushing a cable inside a duct has very short installation span, and you have to be aware of why this happens. This happens because of the buckling effect. Last installation method is the blowing. Blowing makes use of a blowing force of insufflated air. Blowing is then making use of additional machinery producing the airflow injected in the ducts. So this is the typical installation method used for long distances and particularly for microducts and microcables. This drawing here is comparing, for your benefits, the cable installation by pushing with the cable installation by blowing. So actually they are very similar because in both cases there are pushing forces making the cable go inside the duct. However, blowing is supported by air insufflated in the duct, which makes the cable float inside the duct and prevents the buckling from happening. So this is the big advantage of blowing, preventing the buckling effect from happening to some extent. Obviously, physics still play a role even in blowing installations, so buckling will appear, but at much higher installation forces and longer distances, and we will see that as well later on. This installation method allows for 2,000 meters and even beyond easily. So from the three different installation methods that we've seen, obviously the most important and most commonly used ones are pulling and blowing. In this table here, at the bottom right of your screen, we have a high-level comparison of both installation methods. Actually, on the pulling side, left-hand side, we have some requirements. For example, pulling line pre-installed first compared to the blowing on the right-hand side that does not require pulling lines. So there is some savings, and also not only in terms of a cost, but also in terms of time, because you don't need to install pulling lines. Pulling requires equipment at both ends, because you are installing on one side the cable drum and the pulling device on the other side, whereas blowing requires equipment only on one side. The pulling typically carry over regular size cables. It's rare that we pull micro cables. Micro cables are typically installed by blowing. Pulling in the longer distances cause a tensile force very high to the cable, which may lead to cable damage. Forces in blowing are much lower because there is an air cushion keeping the cable inside the duct floating, as we have said before. So the forces are much lower and the risk for damage is also much lower. The pulling is typically done manually or mechanically with a pulling machine and winch. We'll see that later on. The blowing, however, requires a high precision cable blowing machine and an air compressor. So this equipment is additional equipment, and if the quality is up to the expected level, these equipment are not cheap. The pulling best results are got in straight routes because bends cause a lot of additional friction, and tensile forces required to install the cable have to be increased to compensate for that, and then that is again additional risk to the cable. So the best results are achieved in straight routes by pulling. However, the blowing and this cable floating allows the method to cope as well with bended routes, undulated routes. Therefore, the pulling may be effective for short distances, but the blowing is effective on much longer distances. The typical speed is much lower in pulling than in blowing, and we are comparing here typical values of 20 meters per minute with pulling and 60 meters per minute with blowing, so it's 3 times faster. And actually this is a very shy statement here. Blowing can run at much faster speeds than 60 meters per minute. A pulling typically uses big size ducts, or at least bigger size, which is less efficient in terms of the underground space utilization, whereas blowing allows for having a lot of microducts and microcables installed in the same space, making better use of the underground space. On this slide, we're going to see some safety procedures while installing cables underground. The first point that we have to highlight here is to warn you out on the fibers that may transport light outside the visible spectrum. So you would be unable to see the light coming out. And if you look directly at the fiber end or to a connector, that may severely harm your eyes. So never ever look at the end of a fiber or a connector. Another hazard you have to pay attention to is the fiber handling as such. You know that the fiber optics, the fiber core inside are very brittle, and the small tiny pieces of fiber that are extremely sharp can't easily penetrate the skin. So they are transparent and very difficult to find once they are in your skin. So this requires a doctor procedure, and eventually you can easily get infected if not treated. So please be careful with that as well. You are supposed to handle some materials for fiber cleaning, such as isopropyl alcohol, that also may irritate the skin. So please wear gloves as much as possible and always follow the manufacturer's instructions. Another important point here, although it's not directly to the cable installation, is more on the additional procedures, is when you are accessing a manhole. A manhole is supposed to be big enough to host a person inside. And manholes may be accumulating different types of gases. So it is mandatory, and this is a very important point, please apply STC rules on accessing manholes. That is, right after you remove the cover, you have to force ventilation at a minimum rate of 15 cubic meters per minute.
Regards your PPEs, personal protective equipment,
make sure that you are wearing at all times your PPEs, such as helmets, safety shoes, glasses, reflective vest, gloves, and so on and so forth. Last but not least, all the safety measures to be applied on site. Keep all tools and materials in proper order and well maintained. Establish communications across all cable locations. Clean everything that is spilled on site, particularly lubricants, to avoid slipping. Watch electrical hazards and bond all metallic components. Keep hands, feet, loose clothing away from moving parts, and all unauthorized personnel away from the work site. Next slide is more on the pulling and blowing machinery, safety procedures. So insisting on the fact that you should never operate the machines if you are not trained on the machine operations, and that you have to be aware of all hot surfaces, electrical contacts, and so on. Keep your equipment in clean and dry condition at all times, and never ever leave machinery unattended while they are in use. Specifically on the pneumatic and hydraulic systems that are used for blowing, compressors and so on. They are carrying important pressure forces in the hoses and pipes. So pay attention to these points and make sure that the hoses are properly clamped and fixed onto their equipment. Otherwise, when you fire up the equipment, those can kind of explode and hit you, causing some damage to you guys. So this is about making sure that all connections and hoses in pneumatic and hydraulic systems can operate and are properly connected before you start working with equipment.
Let's move on now to the next subject within the fiber cable underground installation. Regards cable drums, they must always be inspected when first delivered by the manufacturer to the contractor's warehouse, also when transported from the warehouse to the site.
Always inspect the cable drums and look for protections removed or damaged, cable ends loose and unsecured, drum flanges broken. So you must ensure that the cable in the cable drum is undamaged and perfectly operational at those sites where you are installing it. If you suspect that the cable may be damaged because something happened during the transportation from your warehouse to the site, or because you saw something abnormal when the cable drum was delivered by the manufacturer, what you have to do is you have to test it. You have to test one fiber per tube with an OTDR at 1550 nanometers. This is a mandatory test, as we will see in the last chapter. Please pay attention to the drawings down here, because they are actually self-explanatory, and an image speaks more than 1,000 words. Here on the left-hand side, you can see the only way a cable drum can be stored, handled, and transported. This is the only way, standing upright, never laying on the sides. You can see here with the forklift how this cable drum is properly transported. All these variations here are wrong. You cannot transport it upside down, laying on the side, hanging on cord, or whatever other installation methods you may think of. This is the only authorized way of transporting it. When using a truck to transport drums from your warehouse to the site, you have to take some precautions. If these cable drums weigh over 200 kilograms, you cannot handle them by hand. You have to use forklifts, trucks, cranes, whatever other machinery you may have, but not by hand. These cable drums have a rotation direction indicated on the side of the cable drum. They must roll on that specific direction indicated by the manufacturer. Then when you are rolling the drums, make sure that there is no object or uneven terrain that may jeopardize the integrity of the drum or the cable. Do not use the cable to pull or move a cable drum. That's strictly forbidden. The cable drums cannot be rolled for more than 50 meters. If you have to go beyond 50 meters, use another transportation device, such as the forklift. And last but not least, pay attention when you're unloading the trucks and using a ramp, because these cable drums may be very heavy. So you have to plan in advance how you're going to control the force of the cable drum rolling down the way. Do not do that without the proper planning.
Regards cable drums transportation, you can see on the top left corner of your slide the proper ways to transport them. All drums must be tightly tied to the truck.
Do not transport drums that are loose, moving away inside the truck. This is strictly forbidden. It's a risk for cables and people. On the lifting procedure, see there is only one correct way to lift a cable drum, by making use of this bar placed horizontally, so the tension is vertically applied to the axle and the flinches are not damaged, which is a potential hazard if you use just a crane without the bar. The weight of this cable drum is high, so the pressures exerted onto the cable drums are high, the horizontal pressure, and this may break the drum and eventually damage the cable. So never use this method, always use this one. On the storage side, we have also to follow some specific rules to avoid a long-term cable and drum damage. Basically, the rule of thumb is that all cable drums must be sheltered and protected against sun radiation, and moist or rain. So the way to protect them is to shelter them. So we are not accepting warehouses where you expose the cable drums and other ODM material to the weather conditions. They must be sheltered somehow. We are not saying that these have to be in specific sealed rooms or whatever. No, we are saying that they must be protected against sun and rain. One more time, insisting on the fact that storing can only be done by placing the cable drums in upright position. This slide is a general statement on the fiber optic components fragility. Optical cables transport a lot of information, and any tiny degradation would be jeopardizing the long-term performance of cable transmission. You guys have to be fully aware of this and keep that in mind every single time that you are handling fiber components. Fiber components are not as copper components. They are very fragile. So you have to be aware of that when you operate all these elements, cables and ODM components. And always read and follow the manufacturer installation manuals. Now we are going to see additional parameters that have to be taken into account while installing fiber cables. We are going to talk about the minimum bending radius. The minimum bending radius is the radius the cable can be bended. You cannot exceed that radius because the mechanical stress that you will be causing to the fibers will produce permanent damage to them. So minimum bending radius is the smallest radius you can bend the cable. Where the minimum bending radius can be compromised in all these typical installation places. For example, cable coils in manholes and handholds, the slack loops. Also in the splice trays and fiber organizers, the fiber coils or loops. All the guidance hardware that we can see down on the pictures have to be set to the proper diameter so that the minimum bending radius is never compromised. Sharp edges, obviously, like manhole and handhole entrances. So if the cable is rubbing the edge, that is not only going to damage the cable sheath, but also compromise the bending radius and eventually damage the core fibers, the fiber strands inside the cable, which is even worse. Also the entrance of conduits, that's another important point to pay attention to.
But how do we make sure to meet the minimum bending radius? Here is the rule of thumb. The MBR is multiple of the cable outer diameter.
So you measure the cable diameter and the minimum bending radius is a multiple of this. There are two values of the minimum bending radius, static and dynamic. Static means that the cable is not in movement, so you are not installing, you are not moving the cable, you are not pulling, blowing, doing anything with the cable. In the static position, the minimum bending radius is 10 times the outer diameter. However, if the cable is in movement, so it is subject to tensile forces because you are installing it, blowing it, the cable is in movement, so there is tensile load in addition to the bend. That is the dynamic minimum bending radius and is equal to 20 times the cable outer diameter. So 10 times static, 20 times dynamic. So please make sure that you are respecting that minimum bending radius at all times and watch out to the points where that minimum bending radius may be at risk. So sharp edges at the entrance of handholds and manholes, duct or conduit entrances. When using pulleys or winches, be aware of that minimum bending radius and set all these equipment if you use guidance hardware, for example, quadrants like as you can see here, or pulleys or other equipment, set that equipment to respect the minimum bending radius of the cable that you are installing. On the fiber types, changing the minimum bending radius, please do not mistakenly get confused between the minimum bending radius of the core fiber inside the cable and the minimum bending radius of the cable itself. Different types of fibers, such as the G657A, B, and so on, are bending sensitive, so they have better bending radius performance compared to the standard G652D fibers. But this is about the fiber core, the fiber strands, not the fiber cable. So the rule is to apply the MBR as a multiple of the cable outer diameter. And in that way, we make sure that all fibers and additional components are safe inside the cable. Next slide is on the maximum rated cable load. This is another important parameter of the cables that must be met at all times. The maximum rated cable load, or maximum tensile load, which is exactly the same parameter. It is measured in newtons, as all forces are measured in newtons. So the maximum rated tensile load, or rated cable load, is specified by the manufacturer. Every single type of cable from every single different manufacturer has physical specifications to be met, and a cable must never be loaded beyond the maximum tensile load. You have to check cable data sheets to find out what that value is. If you don't have the cable data sheets, you must know that STC defines a minimum value for the maximum rated cable load that all manufacturers have to meet. They can exceed that value, which means that the cable is stronger, but they cannot not meet it, not get up to the value. So that is the minimum value. And those values are shown down here on the table. These are the minimum values specified by STC for the maximum tensile load. STC specifies 8 different types of cables, as you can see on the table: the standard ducts, standard buried, aerial cables, standard drops, micro cables for feeder and distribution, micro cables for drops, anti-rodent, and indoor cables. Each of them have different values. Obviously, micro cables, because of their physical structure, they are much weaker than other types of cables. Standard ducts have 1500, for example, for the 48 fiber cables, and almost 3000 newtons for bigger size cables, the 96, 144, 288. So you have different minimum requirements here. If you don't have the data sheets from the manufacturers, you have to make sure that you never ever exceed these tensile forces when installing the cables. Those tensile forces can only be warranted by the manufacturers, of course, if the cable is pulled applying pulling tension to the strength members, not to the cable sheath, not to other cable components. The only element in the cable warranting that minimum tensile load is the strength members. So the pulling forces have to be applied to those strength members. Because cable blowing uses a different technique, this is not applying to blowing or pushing. What factors contribute to increase the tensile force in a cable installation? The cable weight, number one. The heavier the cable, the more tensile force you have to apply to pull it. So the cable weight is number one. The coefficient of friction, as such, that we have seen earlier today. The higher the coefficient of friction, the higher friction between the duct and the cable will be, and the higher pulling force you will have to exert to make it move inside. Bends and curvatures. So if the installation route is bended, that would be also increasing the pulling load. We have already stated the installation spans have to have limited bends, and between bends the ducts must be as straight as possible. The cable stiffness as well can increase the frictional force, especially when the cable goes through bends. So these are the factors that contribute to the increase of tensile forces in the cable. You have to keep them in mind to try to decrease, with all possible techniques that we are going to see in a minute, this tensile force, and keep it under control and below the maximum rated load. So what techniques can you guys use to make sure that all the previous factors are kept under control? You have down here in the next table the techniques that you have to use. The first of them is the breakaway swivels. Breakaway swivels used during pulling control tension, and we will see later on how they are engineered and how they work. Appropriate lubricants to reduce the coefficient of friction, obviously by lubricating the cable. In blowing installations, tension monitors help out as well. They are giving you information about what tensile force is applied to the cable at every moment, especially while using pulling winches or blowing equipment. This is very helpful. Tension limiters like mechanical clutches, stalling motors, hydraulic bypass valves, etc. are typically set to 80 to 85% of the maximal tensile load of the cable, so that you never damage it if some.
Regards twisting and crushing,
we have to use also some specific techniques to avoid this from damaging the cable. Twisting is also prevented by using swivels. This is the breakaway swivel that we mentioned in the previous slide. This is actually having a double purpose, is at the same time making sure that you do not exceed the maximum tensile load when properly set, as well as preventing the tension forces to add on top of the tensile and damage the cable, because these heads turn loosely, so they are actually removing all twisting forces from the installation. On the twisting side, we have also another installation technique, that is the figure 8. Figure 8 installation techniques, as most of you guys know, are exactly engineered to remove twisting. But even though we install the breakaway swivels so that both of them at the same time diminish the risk of cable twisting. As an additional point, fiber cables must not be coiled in a continuous direction beyond 30 meters. This is an STC rule to be respected at all times. It applies while doing figure 8 or while doing any cable slack loops. Fiber cables must not be coiled in a continuous direction beyond 30 meters. Now we are going to see some techniques to avoid cable crushing. Now, basically, you have to protect the cable. This is the rule of thumb. If you are installing cables temporarily, or probably this type of installation is only temporary, crossing roads where the vehicles are passing over, you have to protect that cable. Fiber cables installed along heavier copper cables cannot be installed, so do never install a fiber cable along a copper cable. The cable has always to be subducted. Okay? Install first the subduct and then the cable inside. Pay a lot of attention to ties, wraps, ribs, plugs, and compression fittings, and all other elements that are supposed to hold cables in place, because they are easily over tightened, and over tightening them means that you're crushing the fibers inside. Last, and specifically for blowing techniques, we have the crash test. So we will see this in details when we'll study the blowing installation techniques. Just keep in mind that a crash test is mandatory prior to any fiber blowing. Also remember that the figure 8 installation has to be flipped over if you guys are doing forward feeding to avoid cable kinking. Some words now about temperature and environment protection. Again, rule of thumb is that you cannot install cables in temperatures below -5 degrees centigrade. Cables must be protected from sunlight exposure. We already saw that in previous slides, and hot surfaces. The fiber cores must be protected at all times by hot shrinkable thermoplastics. We are going to see how they work. Last but not least on this temperature and environmental protection, please use aftercoolers while blowing or while installing cables by using compressors if the ambient outside temperature is over 25 degrees. Because over 25 degrees, when the compressed air is injected in the duct,
the temperature reaches
at least 50 degrees, and 50 degrees is a too high temperature for the installation. So you have to use aftercoolers, and we will see that later on in more details while talking about fiber blowing.
another important parameter
is the duct fill ratio. The duct filling ratio is calculated by comparing the cable area that the cable is occupying inside the duct. So it is the ratio between cable area and inner duct area. You have the formula here, and it is important that you respect the maximum duct filling ratio target values. When you are installing cables by pulling in a straight section, we can go up to 65% of duct filling ratio. However, if there are bends, you cannot go up to 65, you have to stop at 50%, so you can only install smaller cables. The blowing is very variable, and we will see why all this difference in terms of duct filling ratio. It can go between 35 and 70%. Okay, so these are the values that you have to keep while installing cables inside the ducts. Remember that cables alone cannot be installed in bigger ducts. You have to subduct it, because that would be a waste of infrastructure. So a big duct like this have to be subducted, and we will see the maximum subducting capabilities later on, and then you can install the cable inside the subduct. Just a very basic
additional
requirement. Prepare the location where you are going to install the cable. This is all we say here. Prepare the place, so you have to have enough space to organize and place your installation equipment properly. Get the utility plans that may affect the routes. Inspect the handholds and manholes according to the network survey requirements, and test the integrity of the ducts. That on one side. Then have a look at the geometry of the duct routes, if they are straight or bended, if they have excessive curvature, try to fix those. You have to plan all those things ahead and try and remove abrupt changes of directions. The last point is to create a cable placement plan before you install the cable. This should be something really helpful for you guys. The cable placement plan is including things such as making sure that there is enough cable in the warehouses, defining the installation methods for each section, inspect the cables and test them if they are eventually damaged or you see some kind of damage on the cable sheath. Define the protection of the existing cables, if any. Check that there is sufficient space around the manholes where you're going to install all your tools and machineries and cables. Safety devices as well as fences, cones, signs and all that, and the traffic management. So this is something that you usually don't do, or eventually you do just the last part of it, but it's something very helpful for you.